Alright, so now armed with the knowledge of minors and cofactors, let's use all that we have learned till now about determinants to solve a problem. So let's say we wanted to solve this linear system of equation x1 plus x2 plus x3 is equal to 4, and let's say x1 plus 2x2 plus x3 is equal to 6, and 2x1 plus x2 plus x3 is equal to 5. All right, so we know from Kramer's rule, and I think one thing I forgot to add about Kramer's rule is that it's not only valid for a linear system with two unknowns, it's really valid for all the cases. So using Kramer's rule that we learned a while back, Kramer's rule we can say that x1 is equal to d1 by d, and x2 is equal to d2 by d, and x3 is equal to d3 by d. All right, where d is going to be equal to 1 1 1 1 2 1 2 1 1. So d is nothing but the elements of d will be the coefficients for all the unknowns in the same order. So 1 1 1, we have the first row as 1 1 1, the second row is 1 2 1, and so we have 1 2 1 here, and so on and so forth. D1 will be obtained by replacing the coefficients of x1 with the scalar terms here 4 6 5. So this becomes 4 6 5, and then we write down all the elements as it is. So this will be 1 2 1, so we write 1 2 1, and then 1 1 1, we write 1 1 1. All right, so by now I think you must find it really easy to at least compose these matrices d1 d2 and d3. So d2 will be what? D2 will be 1 1 2 1 1 2, and then 4 6 5. So we replace the coefficients of x2 with the constant terms on the right side, and then again 1 1 1 1 1 1. All right, and finally writing down d3. So d3 will be 1 1 2, so it will be 1 1 2, we choose a different color, and then 1 2 1, so this will be 1 2 1, and then the coefficients of x3 will be replaced by these scalar terms 4 6 5. So this becomes 4 4 6 and 5. All right, so now in order to evaluate x1 x2 and x3, the next goal would be to evaluate these matrices d d1 d2 and d3. So let me start by evaluating d first. All right, so now d is a is a matrix, or sorry, is a determinant of third order. So it's 1 1 1 1 2 1 and 2 1 1. All right, and remember that from the last lesson we learned that d, determinant of any order n, can be expanded either along any row. So let that row be j. So if we were to expand a determinant along row j, it will be aj1 times cj1 plus a j2 times cj2 and dot 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 plus a jn times cjn. And you can also expand a determinant along a column, any column k. So and if you do so, the answer would be a1k times c1k plus a2k times c2k plus dot 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 a nk times cnk. All right, where c is nothing but the cofactor here. And let's say we choose to expand this determinant d here along the row, and we choose to do it along the first row. All right, so then you can write d here as so you can write d here as a11 times c11 plus a12 times C12 plus A22 times A13 times C13. All right. So now let's look at what C11, C12 and C13 are. So C11 will be equal to minus 1 raised to the power 1 plus 1 times M11. So this will be nothing but M11, and M11 is again a determinant or a submatrix which is obtained from this D by eliminating the row and the column by eliminating the first row and the first column. All right. So this becomes, so if you eliminate this row and the first column, you are left with 2 1 2 1 and then 1 1 1 1. So this is 1. All right. So now let's look at what is C12. All right. So C12 will be equal to minus 1 raised to the power 1 plus 2 times M12, and this will be equal to minus M12. All right. And this will be equal to minus of, you got to actually eliminate the first row and the second column now. So you eliminate this row and you got to eliminate the first row. So you got to eliminate this row and the second column. All right. So now you will consider 1 2 and 1 1. Okay. So you will have let me see again. Yeah, 1 2 and 1 1. All right. And this will be equal to 1 again. And now let's compute what is C13. So C13 will be equal to minus 1 to the power 1 plus 3 times M13, and this will be equal to M13. And M13 will be obtained by eliminating the first row, all right, and the third column. So you are left with 1 2 and 2 1. So this will be equal to 1 2 and 2 1. And so this will be equal to minus 3. All right. So now let's calculate what D is. So D is equal to A11 times C1. A11 is 1. 1 times C11, that is 1. And again A12, that is again 1, times C12, which is again 1, plus A13, which is again 1, times C13. This value, this is minus 3. And this becomes minus 1. Okay. And now you can use the same logic to compute D1, D2 and D3. So D1, I'll not compute it for you, but I encourage you to do it on your own. So D1 will be equal to minus 1, D2 will be equal to minus 2, and D3 will again be equal to minus 1. And so consequently x1 will be equal to D1 by D is equal to 1. X2 will be equal to D2 by D, which will be equal to 2. And x3 will be equal to D3 by D, and this will again be equal to 1. So alright folks, that's all I had to talk about in this lecture. I'll see you guys in the next lecture.